In this problem, I want to solve for x. Writing this given equation, this is going to be 2 to the power of x equals to 5 minus x. Then, let's divide both sides by 2 to the power of x. By doing that, here we're going to have 5 minus x divided by 2 to the power of x. Now, on the left-hand side, this is going to be 1. And on the right-hand side, here, I'm going to have 5 minus x. This denominator can be written as 2 to the power of negative x. Recall, in mathematics, 1 over 2 is the same thing as 2 to the power of negative 1. Now, here, multiply both sides by 2 to the power of 5. Then, here I'm going to have 1 times 2 to the power of 5 equal to 5 minus x, 2 to the power of negative x times 2 to the power of 5. So, switching the sides, here I'm going to have 5 minus x. And this is going to be 2 to the power of negative x plus 5. This is the rule of indices. We call the rule of indices that says that 2 to the power of a times 2 to the power of b is the same thing as 2 to the power of a plus b. So this is going to be equals to 2 to the power of 5. Rewriting this equation, here I'm going to have 5 minus x multiplied by 2 to the power of 5 minus x equals to 2 to the power of 5. And this is the same thing as saying 5 minus x, 2 to the power of 5 minus x equals to 32. Now, I'm going to introduce something we call the Olympiad-level function. And what does Olympiad-level function says? It says that if you have w, recall that if you have the Olympiad function a exponential a equals to a. So here you need the exponent function. So a exponential a equals to what? A. So this is the Olympiad function. And also recall that when you have exponential in natural log of a value, the exponent and the natural log is going to cancel out and you still have a. So these two equations are needed. Now, going back to my previous equation, let me call this equation star. Going back to my equation star, I can rewrite this equation star in form of the Olympiad equation. And what am I going to do? Here, I'm having 2. So using this rule, that is, when I have e exponent ln 2, this is still going to be the same thing as 2. So I'm going to rewrite my 2 in this form. So here, I'm going to have 5 minus x. The exponent ln 2. Okay, this is my 2 written in this form, and the power is going to be 5 minus x equals to 32. Now, let me rewrite this same function in the next slide. In the previous slide, I have 5 minus x exponential ln 2 in parentheses, and outside the parentheses I have 5 minus x equals to 32. Now, here I'm going to introduce the to use the Olympiad function here. Recall that the Olympiad function is w a exponential a. This is going to be a. So we make sure these and these are the same. Now to do that, let's multiply both sides by ln 2. So multiplying by natural log of 2. So here I'm going to have 5 minus x. So this can be written as exponent ln 2 5 minus x. So the right hand side will also be multiplied by the natural log of 2. Okay? Now this is done. Let's have a very good look at this. Look at this. Natural log of 2 times 5 minus x, natural log of 2 times 5 minus x, they are the same. So let's call this a, let's call this a. So this is in form of the what? Of the Lambert. Now here we can apply the Lambert function. Here you have natural log of 2, 5 minus x, exponent, natural log of 2, 5 minus x, equal 32 natural log of 2. Now we can apply this. So applying this rule, then we can say that the answer is going to be the a. And what is our a? Our a is natural log of 2 times 5 minus x, okay, equals to 32 times the natural log of 2. And here, looking at this, dividing both sides by the coefficient of 5 minus x, which is natural log of 2. So on the left hand side, I can have my 5 minus x equals to 32 natural log of 2. Recall, we have the Lambert function on the right hand side too. So what you apply to the left hand side must be applied to the right hand side. That was an omission. So here we have the same the Lambert on the right hand side. So dividing this by this coefficient, which is 2. So rewriting this here, we can have our x to be equals to 5 minus the Lambert function of 32 times the natural log of 2 divided by natural log of 2. So this is what we have. But here, by checking the internet libraries, okay, by checking the internet libraries, plugging these values in the graph, then you can have an approximate value for x by checking the graph, which is 1.716. You can check this graphing online, plug this function in it, and then you can see the approximate value for x. Thank you very much for watching. Please, if you have any suggestion, contribution, kindly put this in the comment section. Thank you very much.